A fluid is defined as a substance that continually deforms or flows under an applied shear stress. Now you might ask, what is shear stress? Shear stress is the internal force per unit area acting parallel to a surface, causing layers of material to slide relative to each other. Unlike solids, fluids cannot sustain shear stress while at rest. In engineering, particularly in aerospace engineering, we study fluid mechanics because almost every system we design interacts with fluids. The air flowing over an aircraft wing, the fuel moving through pipelines, the exhaust gases in a jet engine, and even the hydraulic fluid in control system are all fluids. Understanding their behavior is fundamental to predicting lift, drag, propulsion, and structural load in aircraft. Now that we know what a fluid is, we can talk about its properties. Property 1. Density. Density is the mass per unit volume of a substance. It's expressed as ρ equal to m by v, where ρ is density and m is mass, and v is volume. The SI unit is kilogram per meter cube. In simple terms, density tells us how much matter is packed into a given space. A higher density means more mass is concentrated in the same volume. Another related term is specific gravity, which is the ratio of density of a fluid to the density of water at standard conditions. It is dimensionless. Property 2. Viscosity. Viscosity is a measure of a fluid's resistance to flow or deformation under shear stress. It arises from internal friction between fluid layers moving at different velocities. There are two common expressions. Dynamic viscosity, measured in Pascal second or Newton second per meter squared. It represents the tangential force per unit area required to move one layer of fluid over another at unit velocity gradient. Kinematic viscosity, defined as dynamic viscosity divided by density. Unit is meter squared per second. In simple terms, viscosity is how thick or sticky a fluid feels. Water has low viscosity and flows easily. Honey has high viscosity and flows slowly. In aerospace engineering, viscosity is responsible for the formation of the boundary layer, the thin layer of fluid near the surface of wing or fuselage, where velocity changes from zero at the surface to the free stream velocity. This boundary layer creates skin friction drag, which is a major component of total drag on an aircraft. Most fluids encountered in aerospace are Newtonian fluids, meaning their viscosity remains constant regardless of shear rate applied. Other important properties. Where density and viscosity are most fundamental, several other properties are important in engineering applications. Compressibility refers to a change in volume of a fluid under pressure. Gases are highly compressible, while liquids are nearly incompressible. This property becomes especially important in high-speed aerodynamics. Surface tension is the force per unit length acting on a surface of a liquid due to molecular attraction. It affects droplet formation and fuel behaviors in tanks. Vapor pressure is the pressure exerted by the vapor of a liquid in equilibrium with its liquid phase. At high altitudes, low atmospheric pressure can cause fuel to vaporize, leading to problems in fuel systems. These properties will be discussed in greater detail in later videos when they directly apply to specific aerospace systems. To summarize, fluid is a substance that flows under shear stress. Density determines how much mass occupies a volume and directly affects lift and engine performance. Viscosity measures internal resistance to flow and responsible for boundary layer formation and skin friction drag. Other properties such as compressibility, surface tension, and vapor pressure also influence aerospace systems, especially at extreme conditions. Understanding these fundamental properties form the foundation of everything that follows fluid mechanics and aerodynamics. In the next video, we will go deeper into viscosity, including how it affects boundary layer development and drag on aircraft. Drop a comment. Which fluid property do you find most confusing or important in your studies? Thanks for watching.